In today's session, I'll be speaking about SRE AI agents, which are very popular these days, agentic applications that is specialized in specific domains. And SRE'ing the applications is one of those domains. Traditionally, what we called operation engineers transformed to SRE engineers. There are also workflows defined for some basic operations. For instance, acknowledging an alert, following an SOP, taking some actions and trying to resolve the root cause of the alert with help from the developers of the application. So if we develop such agent, right, if we have something in place that is responsible for taking care of our whole production environment, how we would SRE this tool itself, right? It sounds a bit recursive from that point. Maybe you might thinking about where the hell did this come from? The agents and SRE'ing and a level above SRE'ing it again and SRE it again. Because SRE is a proven way to run applications with performance at scale. So why not we can apply the same pattern when we want to manage the life cycle of these same agentic applications. So briefly looking at agenda, we'll be first welcoming our teammate. I call this as my teammate. I'm not sure whatever you call it, but as an assistant or complementary, secondary, no matter how you call it. And we'll be then take a look at history of how we got there, right? Why do we need these agents in place? Or do we even need this? Is it a defensive approach or something meaningful that we can benefit from? And then we will be focusing on, after the introduction, we'll be moving forward with the core SRE principles, permission, boundaries of these SRE agents. And secondly, observability is very important aspect of SRE when it comes to defining metrics and track the agent performance at real time and get alerted based on the anomalies. And finally, audit trails to be compliant with the rest of our architecture, just like human SREs, how we are how we are collecting the evidence of operations, who did what at when, right? This kind of actions would still be obligated to be proven by these agentic applications. And finally, I'll be touching on the key takeaways and next steps. Briefly about me, Boran, I have a decade of experience in software engineering, DevOps, and SRE fields. I'm passionate about building scalable, secure, reliable systems, the story part. Now I'm part of a security team, specializing in CV management and supply chain security and scanners. And recently I'm hacking on turning how we can turn LLMs into ethical white hat hackers that can be used in the production system internally to make sure we are. We don't need to have a human to act as a intrusion or who wants to intrusion to system. Those could be agents as well as humans. So just recently hacking on this topic. So how did we get there, right? Why do we need agents in action? Is it a remediation to a problem that is not supposed to be a problem? Because often we see like when there is disparity between DevOps teams in an organization, we see ops, like developers blame operation guys blame developer guys. Developers are blamed because they are producing buggy software that SRE can't handle in their allocated time, one by one, tackling the alerts. And then ops can also be faulty when it comes to some unknown networking errors, or maybe those could be like, some hardware-related problems that needs to be looked into deeper. So in these areas, SRE, like agentic SRE tools can help assisting us to solve generic problems, or at least if they occurred in the past, maybe these kind of agents can point us without searching through deeply in the existing conversation history or tickets, etc. So from that point, it can also eliminate toil, right? If we basically apply a simple workflow to it to automate, for instance, like alert, acknowledging an alert and progressing the SOP might easily be automated with these kind of tools. So that could help us, enable us to focus on more strategical initiatives instead of spending some time on the toil tasks. And maybe it's just because of the organizations want to try some experimental POCs that can be productized and marketed if the idea is liked by the consumers and the market stakeholders. So agents can operate 24/7, 24/7 without fatigue, with increased monitoring coverage and speed. Of course, a machine is way much faster than a human when it comes to take actions, run commands, and blah, blah. They can assist, as we said in the previous slide, they can assist by automating routine tasks, incident detection, triage, and remediation suggestions. And integrating the agents as teammates require us to transform some of our traditional workflows, and it requires new models to be put in place. And the whole idea is at some point in the future, the applications, except for a few, some mission-critical ones, will all be designed, built, and operated by AI agents who gained autonomy, right? For instance, from a banking domain point of view, maybe the withdraw service won't be ever it won't be written by an AI agent. Maybe it can be in very long term. But for experimental experimental works, it can be tried on some non-mission critical, some marketing applications that are fault tolerant. We can try these initiatives against those applications, maybe. So I'd like to take a step back here before we actually dive into SRE'ing the SRE AI agent. First, let's talk about how does an SRE agent look like, right? So we trigger the whole system with an alert. Basically, in this system, we are trying to automate a simple workflow that SRE is following. So we trigger the system with an alert, and the alert body should have most likely from which service the alert is coming, and what are the related metrics, right, that we initially grabbed from Prometheus, let's say, and some other related informations that we fed with the alerting body. And then the LLM starts to think about the other metrics that this service is talking to, because it's at this point the agent itself starting to investigate, just like a human SRE. What might be the related logs that I need to look up? So, for instance, checking the tracing part, we can check other services and their logs retrieved from Prometheus, and then the logs from Elasticsearch as well. And this is all done via MCP. MCP is a way to talk to various APIs by an LLM, so that we can retrieve real-time information about our alert and the related in the corresponding service to have a better expanded view of what is happening with this service, and if we need to if you need to have more data or not, right? The initial part will be retrieving the real-time data for that service. And the second part will be using RAG or some system. If we index all the, for instance, previous Jira tickets, previous incidents, and their related Slack conversations as Q&A, and as well as the service documentation repos into a vector DB, so that the agent itself can make some inference on, hey, this instance happened in the past, and if I follow this flow, that might resolve the alert, right? Because there's a proven path that we follow in the past, which is solving the alert. And then combining this with the real-time data, the LLM now starts to make reasoning, right? The agent itself, by using the LLM power, it can create some meaning that, hey, I can go ahead and this looks to be from this service, a parameter change, for instance, needs to be done. So that, again, I can just go ahead and open a PR to fix this issue. Or using MCP remediation. MCP is bidirectional, right? This is not read-only, so we can simultaneously read something and write back to the same sources. So if there are already pre-built MCP callable scripts in place, the agent itself can call those scripts via MCP and then try to resolve the alert. And in the meantime, while these are happening, if it's a big major issue, then the LLM, the SRE AI agent can itself declare an incident and just update the incident body with its findings, right? I followed this step. As an outcome, I got this, and as a next step, I'm following this, and blah, blah. If it's from a Jira ticket, it can also fed a Jira ticket with the recent findings. So moving on. So what changed, right? From that perspective, it looks very like a human SRE is following the usual workflows, and then trying to diagnose an alert and trying to find the root cause of it and fix it. The answers lies in the question, I guess. This is autonomy. I see this as a breaking point, breaking change, right? Before that, computers had no autonomy. For instance, Kubernetes was a state-of-art application, but it can't maintain its own life cycle itself. Someone else needs to be, someone else needs to interact with admin endpoints to maintain the application life cycle. So from that point, we are in the middle of a change that the machines can make their, the machines can decide something and they follow this path to take some actions, which is very similar to what a human SRE is doing. At some point, the agent itself can also say, hey, to be able to do that, I need to escalate my permission, just like a human, right? So what happens if we don't have a correct permission boundaries? I just want to put this, I don't want to talk about Terminator because we all know about it, the Skynet moment. But Cassandra is one of the recent series that Netflix is offering this year, I guess, 2025, is questioning like what happens if machines have no clear boundaries, right? Permission boundaries, or they don't listen what they are told to, right? Of course, this won't happen in our production system in that tragic way. Maybe the Cassandra in the spoiler alert, Cassandra is torturing the households. I'm sorry. Sorry for the spoiler ants. But yeah, I mean, similar scenarios can happen in also in our production system from time to time if we don't have a clear permission boundaries. So from that look, my approach is like, let's question the statu quo to assess whether or not we are production ready for AI agent implementations. For instance, like your manager ever asks you to examine or like evaluate whether or not our production system is AI agent ready, you can ask these questions, right? For instance, like in terms of permission boundaries, do we know what our agents are doing right now? And can we stop them if needed, right? And which commands do we need to run to stop them, and how hard it would be? Like, would there be additional approval mechanisms that needs to be given and things like that? And how do we ensure AI agents don't overstep their roles accidentally or intentionally? Is there a way to log these requests in a single data source, in a single, that we can visualize them in a single dashboard, let's say? And maybe third question is a bit interesting. Can our current access control model handle a fully autonomous AI acting on our infrastructure? I'm pretty sure most of us don't have this because we need to implement more safe guardrails on this. And how we can cryptographically enforce trust boundaries for agents, because we know they act faster than humans can review at some points, right? Not only for agents, but also for other external intrusions from some malicious actors. So, I tend to approach is like the principle of least privilege is here to stay. So just granting only necessary permissions to minimize the risk and prevent unintended actions. The second part, promoting hierarchical role-based access control, I mean HERBAC, is something I talked in my previous session in all-day DevOps, if I remember correctly. But it was the whole session was dedicated to it, like how we can create such boundaries. That is AI agent implementation compatible. And then, for instance, the benefits of Herbeck is that you can revoke the permissions after use, and then these permissions could be inherited from a human, whether be a manager level or maybe higher. But yeah, just the revoking part is very important, so that each time we need to go into an approval process for this. And then finally securing it using a cryptographic methodology. Like for instance, for post-quantum, we have lattice-based signatures and hashes, which is really hard to break for these hard quantum computers as well. And then finally, like once we get in that stage, we can from time to time review the permissions and this is also for auditing requirements and the compliance requirements as well. And we can also revoke the unnecessary and risky privileges if we catch any during these review processes. And then we can also implement alerting just for this permission, overstepping permission problems, right? There could be some dedicated alerts for it. So the second part will be watching the watchers, putting some, exposing some metrics and putting some props to track the performance of these SRE agents. In that case, we can treat these agents as any other service components running in the production system. So we'll be having SLIs, SLOs, and SLAs. But that raised the question: what is a good metric, right? What we should track? So at that stage, I can recommend exposing some metrics from the area where the decisions are made, which is the LLM reasoning parts here and here. By the way, this is the same diagram, just upside down to show these metrics more explicitly. And these are actually action / decision. I mean, these are actually decisions and the / actions, right? How did we end up this decision? Using what query? Okay. And using these metrics, for instance, we can define SLAs, SLOs and SLIs, right? For instance, for the first metrics might be accuracy. The accuracy, we can say, we can measure this either by human, human decisions that. I mean, for accuracy, I can recommend actually it's both. I can recommend to decide whether we are resolving the root cause alert by our actions taken by SRE AI agent, or it could be just humans, right, reviewing these actions. So the SLO target would be something like 5 to 95% of accuracy over a 30-day window. And then what happens if we breach this? The accuracy drops below 90%. For instance, for more than 3 consecutive days, we can think about retracting the agent from taking some actions, or maybe more, we can disable it for some certain days to retrain it, or tweaking RAG to a better state. Just following the usual troubleshooting patterns on these AI agents. And the second one is MTTR, mean time to resolution, for the parts when we are making accurate remediations. For those that are not accurate, we don't have to look at MTTR. And the final metric would be rollback frequency, right? How frequently we are rolling back the agents' actions, the SRE AI agents taken. So, for instance, like the SLO for this one, if we are less than 2% of all AI generates to be rolled back, it means like we have a very high accuracy rate, and it's good actually. And again, like if the SLA is breached, then we need to consider maybe investigation, like starting investigation processes or troubleshooting incident management. Yeah, we can declare an incident to troubleshoot on this whole agent application. So once you have all these metrics in place, this is from CloudWatch, Google Cloud metric exporter. From a POC environment, but our agent is exposing its metrics, and we are seeing the accuracy is almost 100%. From time to time, the MTTR is peaking to 50 minutes, and if we look at here in trend, there are some accuracy drops as well, and if we look at the rollback dashboard, our human SREs had to roll back some of the SRE actions taken manually, so this caused the SLA breach. So at that case, we need to troubleshoot on the agent to check what we need to fix, either tweaking RAG or MCP endpoints, and maybe feeding more data to agents to increase the accuracy. And when it comes to audit trails, it's actually specific to general standards that humans are obligated to. For instance, when an action is taken, at which phase, from whom, who did this operation. So just like following the similar pattern, we should also log all the decisions and inferences taken from agent, SRE AI agent, and then we can integrate those into our existing monitoring system, and regularly, as I said in the very first permission slide, from time to time we need to get back to those permissions to revoke some unnecessary parts. And this is the key takeaways out of the session: establishing a fine-grained access control to prevent overreach, implementing comprehensive logging and monitoring, tracing parts for our agents, and then defining SLOs, SLAs, and SLAs for accuracy, MTTR, and rollback rollback situations, and then evaluating all of this we can regularly come back to tweak some parts to make this agent better actually over the time, which means continuous improvement. And that's it from me actually. We can switch to Q&A. Any questions so far? Yeah, please. Can you repeat the question? So the question is, how do we? I can't hear you very.
Are your agents in use?
So our agents are only in POC stage right now. I'm planning to be. Pardon, by the way. The question was the agents are shown in the diagram is in GitHub or somewhere that we can pull and run. It's not yet, but I'm planning to push the model with metrics because the metric exporter is another part of that agent. Meaning like the metrics that we are feeding to Prometheus is not like fire and forget type metrics, right? That is increasing the counter or gauge or histogram based data fields. Instead, the accuracy means like we need to calculate, right? For instance, an agent is taking an action, and a human review should verify this action is okay. This action is solving the root cause. So this should be another part of this application, right? It needs to be calculated separately. Maybe not in real time, but still we should feed some data to Prometheus. So I'm planning the whole structure to publish in GitHub in a few weeks or so. Any other questions? Yeah. Hallucination is very nice part. I'm going to be taking yours next. So how do we deal with hallucinations, right? Especially it can happen if, like, we can catch these behaviors by breaching the SLAs, right? For instance, for consecutive 3 days, our accuracy is below than, let's say, 95% something. As a policy, we can say, we can enforce that the SRE team itself need to conduct incident management on this case. That could involve even retraining the whole agent, retraining the whole LLM data that the agent is using under the hood. So the hallucinations can happen, but that evolves us to maybe retrain the data, retweaking the RAG module itself, or maybe there might be some buggy parts in the agent application itself that we need to review and fix, right? So it's again, based on the SLA breach, we can take some actions on this. Any other question? Yeah. Quick one.
In the workflow, you are suggesting automated remediations through MCP, but you said you are in POC, so how much longer it will take until we will trust AI to make automated remediations without human?
Yeah, so the question is, so to trust back to the agent, right?
To make automated remediation.
Yeah, to make automated remediation. So for that one, I can recommend leaning on error budget burning alerts instead of just focusing on maybe SLOs, meaning immediately we can't move it to production. Maybe it can stay. It can still run. It can still be running in production, but in a advisory mode, right? Not in enforcing mode, just like from RHEL. So like for a couple days, we can let it to be soaked in this production, and we can check carefully how they are taking some actions, either better accuracy or not. And then based on this data, we can evaluate switching it back on or not, right, for a couple of days later. And how much also do we have the error budget burn? I mean, like how fast we are burning the error budgets based on the SLO charts. If we still have some error budgeting perspective, then we can immediately switch it on and then switch it off again. But it should be under the SLO policies. And yeah, that's it from me. Thanks for your time.